So most of the work done this sprint in terms of data processing and pre-processing was in exporting our data and splitting it in a way that can be used by machine learning models. So as we can see here, this is the code that does most of that work. And what results from that is this process data folder. It's split up by chunk length. So each one of these represents the length of chunks that we're using in processing in milliseconds. And if we look into one of these, we can see that we have a few different things here. So the three sort of types of data are this num, which is numerical data, this Fourier transform data, and ML spectrogram data. So we also have these historical data. And what this means is it includes previous chunks as well as part of the data. And hopefully we can take this data and use it in machine learning models in order to train them.
To cluster in hill from X hill, I tried unsupervised learning. Before I applying the algorithm, I analyze the data. There are this amount of nothing, in hill, X hill, and noise. The Fourier transform gives me 9,000 dimensions for each chunk of data, so I use the PCA to decrease the dimension down to 2. Here's the result, and then I apply the k-mean algorithm. The algorithm method gives me the good number of cluster is 4. However, the final results gives me this. Most data are clustered on one group and a few on the other 3. So this method is not satisfiable. Then I try the dbScan. dbScan gives me the result like this. There are only 3 group of data, which is not as what we expected. So I believe both methods just failed.
Supervised learning, I tried two different models, random forest and XGBoost. For the random forest, I tried different data set, and the 400 MFCC his dataset is the best for the random forest. And I feed the data size, gain the accuracy, it's about 45%. I know it's low, so I try to use the random search to find the best hyperparameters. Now we get the best parameters, then the accuracy is 47%. It's still low, but that's all I can do right now. For the XGBoost, I did the same thing as the random forest, and then we built the XGBoost classifier and found out the accuracy is kind of low. It's only 7%.
One of the features that we worked on this sprint was that of the recurrent neural network model, or RNN for short. Basically, what the RNN does is, with the given training data that we import, it runs it through the model one time, and then it reprocesses that data again. So it takes the output and puts it back as the input for this model to see if it can obtain a better result. However, in this sprint, it does take a while to run, took around an hour or so, and it did only give an accuracy of around 16%, which is not very good for our use case. So in the next sprint, we plan to increase the model's accuracy and see if it's a viable option as compared to the other models that we are currently training.
Hi, this is Dan, and in Sprint3, our team is primarily doing model training, and I was working on convolutional neural network and the feed-forward neural network, and we're thinking to the sprint plan, and so the accuracy for the CNA is around 0.39. And the accuracy for the FFNA is around 0.38. I've been trying a lot of combinations of parameters, but the results were still not very satisfactory. So in the next sprint, I will continue to work on this as well as the plans in the next sprint.